Hello my dear children, in this exercise 5.5 exercise 5.5 today we are going to discuss differentiating the functions with respect to x by using logarithmic differentiation by the method of logarithmic differentiation. But in the question they will not mention, they will not ask you use the logarithmic differentiation like this. They won't mention it. By observing the question we have to use this logarithmic differentiation method. Okay my dear children, the entire exercise is based on the concept of logarithmic differentiation, but we face there are two types of sums. in applying in applying the concept of logarithmic differentiation, we face two types of sums. See that type 1 sums. In this type 1 sums, there is only one term on both sides. If you write an equation, we write y is equal to like this. Okay, my children. So the in the equation there is only one term on both sides. So see these questions in that exercise 5.5. Question number 1, question number 2, question number 3, question number 5, question number 14 and question number 15. All these are of type 1. If you observe these questions, in the given functions there is one and only one term. Okay my dear children. Type 2. In this type 2 there are two or more terms will be there in the given function. Whatever the function we are going to differentiate, in that function there are two or more terms will be given. In that case, how to find the differentiation? By using the logarithmic differentiation. The question numbers 4, 6, 7, 8, 9, 10, 11 and 12. All these questions are of type 2. If you observe these questions, the functions are defined as sum of two terms. Okay, my dear children, just a small difference in finding the differentiation of type 1 functions and type 2 functions. There is no lot of difference, a small difference is there. Please observe the difference. Okay my dear children, are you ready to listen the class? Right. Now come to the question number 1. Previously I told you question number 1, 2, 3, 5, 14 and 15. All these questions are of the same type, type 1. Okay my dear children, if we observe the function, there is one and only one term which we are going to differentiate. So we follow these steps. Okay my dear children, see the first question, question number 1. Differentiate cos x into cos 2x into cos 3x with respect to x. With respect to x. Okay, my children. So let y is equal to, we follow the first step. We assume that given function is y. So y is equal to cos x into cos 2x into cos 3x. This is the first and foremost step. Okay, my children. After that, immediately after writing the step, we take logarithm on both sides. Remember these steps, my dear children, carefully. By taking log on both sides, we get here LHS as well as in RHS, we are taking log. So log y is equal to log of cos x into cos 2x into cos 3x. Understood this step, my dear children? We have taken logarithm on both sides. This implies log y, I wrote LHS as it is equal to, if we observe the RHS, the function in RHS, it is in the form of log of ABC. Use a logarithm property here. What is the logarithmic property? Log ABC is equal to log A plus log B plus log C. we use this logarithmic property. So log a means here cos x, so log of cos x, plus b means cos 2x, so log of cos 2x, plus c means here cos 3x, so log of cos 3x. Understood this step, my dear children? By using this logarithmic property, I wrote the RHS part like this. Understood, my dear children? Right. So here we used the logarithmic properties at utmost level. After hereafter we cannot use the logarithmic properties. Further we cannot use the logarithmic properties. Understood, my dear children? So we start the differentiation part. So differentiating with respect to x. We are taking the differentiation on both sides with respect to x. Then what is the differential operator here? D by dx. Right. So d by dx of log y is equal to d by dx of log of cos x plus log of cos 2x plus log of cos 3x. Just I wrote the differential operator on both sides. Understood this step, my dear children? Right. This implies if you take LHS, if you observe this function, it is in the form of d by dx of log x. But here in the place of y, x is there. But you assume that y as x in your mind. So d by dx of log x, what is the formula? 1 by x. So 1 by x means here y only. Remember this point, my dear children. Into d by dx of y, whatever we assumed in our mind as x, we have to differentiate again here. This is called chain rule. Okay, my dear children? Right. Is equal to, if you observe this function in RHS, it is a function defined in the three terms. So we differentiate each and every term separately. Therefore, I wrote d by dx of log of cos x plus d by dx of log of cos 2x plus d by dx of log of cos 3x. Understood this RHS part, my dear children? Because three different terms are there, so we can differentiate each and every term separately. So I wrote this step. Understood, my children? So here I wrote d by dx of log x is equal to 1 by x. I used this formula in LHS. Okay, my children? Right. This implies 1 by y, d by dx of y. What is the value of d by dx of y? dy by dx only. So dy by dx I wrote here. Understood this part in LHS, my children? Right. Is equal to. Now come to the first term. We are differentiating each and every term in RHS separately. Okay, my children. So first term d by dx of log of cos x. Again it is in the form of d by dx of log x. Okay, my children. The utmost function can be considered first. The remaining part is considered as x. Okay, my children, remember this point. So d by dx of log x. Don't take directly d by dx of cos x function. Okay, my children. So d by dx of log x. What is the d by dx of log x? 1 by x. So 1 by cos x into d by dx of cos x. Because we assumed here x cos x as x. So we are using here chain rule. Okay, my children, understood the differentiation of the first term? Right. We follow the same procedure for the remaining two terms also. So d by dx of log x, it is also in the form of d by dx of log x. So 1 by cos 2x into d by dx of cos 2x. Understood this second term, my children? Right. Plus d by dx of log cos 3x. So 1 by cos 3x into d by dx of cos 3x. So in this step in RHS, I used in LHS d by dx of y means dy by dx. In LHS I used this result, and in RHS I used d by dx of log x formula, that is 1 by x, and I used here chain rule also. Understood, my dear children? Right. This implies 1 by y dy by dx is equal to 1 by cos x into minus sin x, because dy by dx of cos x is minus sin x. So I wrote minus sin x here. Understood, my dear children? Right. Come to the second term. Plus 1 by cos 2x into here d by dx of cos 2x is there. Its differentiation is minus sin 2x into d by dx of 2x. Understood this is second term, my dear children? Right. Now come to the third term. Plus 1 by cos 3x into d by dx of cos 3x minus sin 3x into d by dx of 3x. Understood, my dear children, the third term? Right. Here I used d by dx of cos x is equal to minus sin x formula and also chain rule. Okay, my dear children? Right. This implies 1 by y into dy by dx. I wrote LHS part as it is equal to, by simplifying the first term, what will you get? Minus sin x by cos x. Understood the first term, my dear children? Right. By simplifying this part of the second term, we get minus sin 2x by cos 2x into here d by dx of 2x is there. If you observe that term, numerical coefficient is there. So we can write outside. We can take it out. So 2 into d by dx of x. We differentiate the remaining part. Understood this part, my dear children? Right. Now come to the third term. By simplifying this part, what will you get? Minus sin 3x by cos 3x into, here also if you observe, 3 is a numerical coefficient. So we can write it outside. 3 into d by dx of x. Understood this third term also, my dear children? Right. This implies 1 by y dy by dx is equal to minus sin x by cos x. What is there? Minus tan x. Minus 2, because here numerical coefficient is 2. In general, we write numerical coefficient of every term at the beginning of the term. So minus 2 into sin 2x by cos 2x can be written as tan 2x into d by dx of x. What is the value of d by dx of x? 1. Understood the second term, my dear children? Right. Now come to the third term. Here 3 is a numerical coefficient. So I wrote that numerical coefficient first at the beginning of that term. So 3 into sin 3x by cos 3x can be written as tan 3x into d by dx of x value is 1. Understood the third term, my dear children? Right. So in this step, I used this result. Sin theta by cos theta means tan theta and d by dx of x value is 1. Understood, my dear children? Right. This implies 1 by y dy by dx is equal to, by simplifying the first term, we get minus tan x. By simplifying the second term, we get minus 2 tan 2x. By simplifying the third term, we get minus 3 tan 3x. Understood this step, my dear children? Right. This implies, finally, we have to find dy by dx. So differentiation part is also over. So we send this y to RHS. This implies we get dy by dx is equal to y into minus tan x minus tan 2x minus 3 tan 3x. Understood this step, my dear children? Right. This implies dy by dx is equal to, what is meant by y here? At the beginning of the question, we assumed y is equal to cos x into cos 2x into cos 3x. So again we rewrite its value here. So cos x into cos 2x into cos 3x into, we write this entire function as it is. Understood that step, my dear children? Right. This implies dy by dx is equal to, dy by dx is equal to minus, I have taken out minus common factor from the three terms. I have taken out minus 1. So minus cos x into cos 2x into cos 3x of tan x plus 2 tan 2x plus 3 tan 3x. This is the value of dy by dx. Understood, my dear children? Right. My dear children, please try these questions. Question number 2. If you have any doubt, you can refer example 30. The question number 2 is the same as example 30. Question number 3 in the exercise. If you have any doubt, you can refer the example 32. This question number 3 is also same as the example 32. After that 5, question number 5 in the exercise, question number 14 and question number 15. Because all these questions are of type 1, because there is only one term in the given function. Okay, my children, will you try it? Will you make an effort to do the sums, my dear children? Right.